In this next step, we're going to read a relative humidity and temperature sensor and then output the data to our OLED display. And then lastly, we're going to actually write a function to calculate the dew point temperature from relative humidity and temperature, and also add that to the OLED. So if you look on the down-facing camera over here, we still have our setup from last time where we have established communication with the SPI version of the OLED, and here's our little AM2302 or DHT22 relative humidity chip. Like I said, uses power, ground, and then one digital pin that's going over here to pin 2. Also requires a 10K resistor jumpered between the signal cable and power, or a pull-up resistor. There's really good tutorials on that on the web. Here's one on the Adafruit website, but there's lots of others. Okay, so the first thing we need to do is see if we can communicate with that chip before we add the OLED. So I'm going to go up here and just pull up a blank sketch. Again, we do need a library to run the DHT22 sensor. So if we go to Sketch, Include Library, and if you go to Manage Libraries and type in something like DHT, you'll see some libraries come up, the Adafruit libraries, and I've already installed this DHT sensor library version 1.2.3. So you'll need to do that first. Then you can load up an example like we often do. I'm going to go to Example, and go over here to my DHT library. If I can find it, there it is. There's something called DHT tester. Let's take a quick look at it. It loads the DHT library. Then you define which pin you're going to use for communications. You have to tell it which type of DHT you have. There's more than one version. We have the 22, so you want to uncomment that. Then in the setup, it establishes communication with our serial monitor and starts the actual sensor. Down here you can see it reads the sensor, humidity, temperature, and temperature in degrees Fahrenheit. And then it prints the results to the serial monitor. So this is just a way to establish that the sensor is working okay and that we're properly connected. So I'm going to upload that. Let's double check our communications. Right board, right port. It's uploading. I'm going to do the serial monitor. And here's the output. So it's 27% relative humidity, and the temperature is about 22 degrees C and 73.2 degrees Fahrenheit. Also calculates the heat index. So here we've just done this first step to make sure that we can read this sensor. Now we want to take this output and put it over on the screen of our OLED. We also want to calculate the dew point temperature and also print that on the OLED display. So I've already written a program to do this, and you can see that it's basically just a mashup of our OLED test program and our DHT sensor test program. So let's look at some of the details here. We have to include the SPI library, which comes with the Arduino. Here's our SSD1306.txt library from our previous work in lesson in the part 1 of the lesson. We defined our pins that we're using for our OLED display. We also have the include library for the humidity sensor. Tell it what pin we're using for communications, what type of sensor that we have. Recall there's different versions of this sensor, so we have to tell it which one. And then we define the sensor object here. In the setup section of the program, we basically initialize the humidity sensor and initialize the display. And then here's the main loop. Went ahead and grabbed the time again in case I later wanted to calculate how long it took to do these calculations. When the program starts, I read the humidity value, read the temperature value, got those now in memory in variable h and variable t, defined as float. It's a floating variable. And then the first thing I do is I'm going to write 3 lines on my display. The first line, I'm going to use a text size 2. Okay. I'm going to leave that. That's going to make everything from here after text size 2 a little bit larger so we can easy to read. I'm going to move the cursor to row 1, column 1. Write a label, temperature degrees C. Move the cursor over to the right, still in row 1, but now in column 65. And then I'm going to actually print the temperature with 2 decimal points, or with 2 numerals after the decimal point. Then I'm going to add just a space after the variable just to erase any remaining graphics that might be there. Now I'm going to move down 2 rows. Notice up here I was in row 1, column 1. Now I'm in row 3, column 1. So I moved down 2 rows and basically did the same thing, but now printed the label for relative humidity and then printed out the humidity value again with 2 numerals after the decimal point. Finally, I move down 1 more line, or move down to row 5 and print the dew point temperature. Now here's something unique. Here's where I say Tdew, T comma H, but you notice I didn't define Tdew up here anywhere. Where is Tdew coming from? Well, I wrote what's called a function to do that calculation. Here's the function. Let's look at the actual math first. This is a really common formula for calculating dew point. This is from the, I believe, University of Arizona website, their weather library system, but this is in lots and lots of textbooks. And this is basically coming from the equation used to calculate saturation vapor pressure. If you take the measurement of actual vapor pressure and put it back in there into the formula, you can back out the dew point. And so there's this variable B that's calculated first, and then the dew point is calculated from variable B. So a nice setup here for us to actually almost in the perfect form. Let's just copy this for grins and compare it over here to the actual function that I wrote. So here's the function. Let's just paste this in our program temporarily. So here's my function. This is how you define functions, and we're going to do this a lot. This is after the main loop. Okay, so recall this is just our comments down here. We say that the function is going to return a variable that has of type float. The function name is Tdew. Inputs to the function include temperature, also defined as a floating variable, and relative humidity, defined as a floating variable. These variable names right here are unique to this function. They're not going to be used up in here, capital T and capital RH. So then we calculate that variable B right here, notice that the natural log in C is log, okay, not ln. So that's not log base 10, that's actually log base E. So you can see my relative humidity and temperature data coming in here. Once I have B, then I use this special word return. This is what the function is going to return, and that's the second half of my equation, the actual dew point. So when you call this function, you can just put in the value for T, the value for relative humidity, and it's going to return the dew point temperature in degrees Celsius. And that's exactly what we're doing right here. And so now you can call this over and over again or from multiple locations within your program. Functions are really powerful and you'll want to use them a lot in your programs. Toward the end of our lessons, I'll show you how to actually put all these functions in a library so they don't even appear in your code. You can just call them whenever you want. I'm going to go ahead and delete this for now. So that's how the program works. So it's going to loop through here over and over again, but every time it hits this Tdew, it's going to jump down here and do this calculation, jump back, returning the dew point temperature. I also put a little delay in here. This typically with the DHT22 sensor, they can only collect data about every 2 seconds, is about as fast as they can go. So I knew this took about 300 milliseconds, so I added a little bit of a delay just to slow things down. So we should hopefully see our OLED update about every 2 seconds. Okay, so we should be ready now to download this into our Arduino. Let's just check to make sure it's going to compile. And looks like it did. So I think we're okay. So let's go ahead and upload it. Again, if you need some help wiring the DHT sensor, remember that you can look up, there's lots of websites that show you how to do that. You do need a 10K resistor jumper between pin 2 and power. So you just need the little sensor and a 10K resistor, one digital pin, and you're good to go. So let's upload this now. Says it's done uploading, and now let's go over to our down facing camera and see what we've got. And it's looking pretty good. Temperature is 22. Hold this up here, see if you can see it. Temperature is 22.2 degrees. Relative humidity is close to about 30%. And the dew point is 4.38 degrees. That makes a lot of sense for as dry as it is in the room. If I blow on the sensor, see it responding, humidity jumping up to 45 and the dew point going up like we would expect. So working nicely. So now we have a nice system that's reading the data from the relative humidity probe and posting it about every 2 seconds to our OLED display. Really nice, crisp display, easy to read. So you can see that it's not too difficult to incorporate these OLED displays into a little monitoring system. And the next step is to go ahead now and put what we've learned about this OLED into our bigger or larger data acquisition system, and that has the real-time clock and that has all the other features. I'm going to just show that to you real quickly, and then we can look at it more in detail. I've got it set up right here, and let's just review this really quickly. In this case, I'm using the Adafruit Metro, still uses just like an Arduino, has the same form factor, but I've been really liking this board for prototyping, and it's been working great. But of course, any program you write for the Arduino will work just fine on the Metro or vice versa. We see things that we've used in previous lessons. Our SHT31D relative humidity and temperature chip over here with an I2C interface. Here is our real-time clock. plugged in here. It's also using an I2C interface. So I put them together. Notice how I just daisy chained the I2C wires together. So it makes sense to put them close together. Here is our SD card. All right, over here. I'm using the Adafruit version in this case. And I'm going to put in a little SD card so it's ready to go. What's new is our OLED display, wired just like we did in our previous example to the same pins. Okay, so we've got a lot of the digital pins occupied now. Okay, but we're able to put this all on a half-size breadboard and it's ready to go. I'm going to plug this in now and download the program that has the newer version, includes the effect of the OLED and our new function and all the things that we've been learning. Okay, actually I've already got it in there and it's actually taking off. It showed me what file it was going to use, and here it is running. You can see, I don't know if you can see it very well. I'm printing the date and time across the top that's coming from my real-time clock. The temperature and relative humidity as read by the SHT31D. And then finally the dew point temperature calculated with our new function. So I'll go ahead and post that code so you can take a look at it, and maybe I'll go ahead and do a walkthrough in the part 3. But even if I stop here, I think you can put that all together. It's really great to try to take these pieces and put them together yourself and see if you can get it to work, and modify it and customize it and make it your own. See if you can change the display. But this is great because now I can see if my real-time clock is properly set. I can see the data from the SHT31, and it's logging the data over here to the SD card, as we might expect it to. Okay, if I pull this card out now and put it in my computer and open it up with Microsoft Excel, it would now include the dew point temperature as one of my columns. Okay, so here we have a full-blown, very nice relative humidity and temperature data acquisition system. Granted, it's on a breadboard, but moving from this breadboard system over to something more permanent is not as hard as you might think, and we've learned a ton in the process about data acquisition and control. So adding a display, great feature, and something that you may want to consider when building your own data acquisition systems.